Right, the continuation of bar bending schedule. So how we are preparing a bar bending schedule. So there will be a lot of process and stages is there. The preparation of bar bending schedule. The first stage is bar mark. See, tag different types of bar available that will be used in a column and beam and slabs. So identify where the mark is provided, where the bar mark is provided. So in the sheet, the drawing sheet is available, or otherwise who are available in the site engineer with their indication or with this permission where the mark is where the cutting of bar is placed or marking is provided. So based upon that identification of a bar mark and the diameter mentioned the diameter and steel bar against each bar mark. See how we are calculating the number of bars required. So there is some formula is given in the slide. Length minus 2 into cover or spacing plus 1. So this is the formula for number of required for numbers of diameter, number of steel bars are required for column and beam. Not only column and beam, and it is also useful for slab also. Then shape and size. So generally the drawing it represented and the size and shape of the reinforcement bar. Then cutting length also depending upon the diameter, angle, number of bends, slabs, and type of hooks and type of steels this specified. And then move on to the important points while preparing a bar bending schedule. So, what are the points required for bar bending schedule is nothing but unit weight of various diameter of bars, development length, and lap length, and lap location, bends, and end hook. So hooks are generally nothing but it is a longitudinal steel bar or steel bar with the ending some bend is provided at the end of the steel bar that is known as hook. So hook generally end hook 90 degrees hook and 180 degrees hooks are also bend in these angles, and bends 30 degrees and 45 degrees and 60 degrees is preferred. So if you select the 45 degrees, then d by sine 45 minus d, then you will get 0.42 into d. So that is the formula for if you maintain 45 degrees angle, that is equals 0.42 into d. D here d is equals to diameter. If you take a angle 30 degrees, if you place in inclined direction, so that is d by sine 30, which means 2d. So d is nothing but diameter of the bar. So generally the formula is 2d. And lap location. Lap is nothing but the joint between steel bars, and lap length. The center to center lap length. The formula is 1.3. I welcome to all to the course of quantity surveying and valuation. In this subject, now I am going to discuss about one of the topic in unit 3, that is bar bending schedule. So in this session, what is mean by bar bending schedule and how to prepare a bar bending schedule and how to estimate the bar bending schedule and what is the bond between bends and the bonding between concrete and steel, and where it is applied. The bar bending schedule is where we are applied. So we are applied at slab, beams, columns, and splicing and the couplers. So in those cases, we are applying bar bending schedule. So I am Satish, assistant professor in Anurag Engineering College, Department of Civil Engineering. So now first discuss what is mean by bar bending schedule. So this bar bending schedule concept is in the reinforced cement concrete work. Generally, the reinforcement cement concrete work will be divided into two categories. One is the concrete work, the second one is steel work. Concrete work is nothing but whereas the process of a shuttering and centering and binding of a steel, so those three are considered as a one item. And coming to the steel bar and bending is these two items are considered as a second part or second item. So now what is the definition of bar bending schedule? See, bar bending schedule definition is nothing but it is the process of cutting, bending, and the detailed information about the steel bar is known as bar bending. Bar bending simple. See, what is meant by schedule? Scheduling is nothing but it is the process of list of complete information or complete details of steel bar, which means the marking portion of steel bar, the size of the steel bar, the number of bars required, and the length of the steel bar, and the weight, unit weight of the steel bar, and what is the placing of steel bar. Those are the list of the bar bending schedule. Now move on to the this topic. This is the bar bending schedule diagram. In this diagram we are simply identified it is the process of cutting and bending of a details of steel bar. If you observe these diagrams, the diagram indicate a complete enclosed area, and the steel bars are cutting and bending some shapes. Different shapes are there. So how the bar bending schedule will be taken? There will be two methods of bar bending schedule will be taken. So the amount of bar bending schedule, the cost of bar bending schedule for separate 20 to 25% of the cost of RCC structures. For example, RCC structure, there is some column is there, some slab is there, some footing work is there. So entire RCC structure is a 100%. Now the reinforcement steel is provide 20 to 25% of the total RCC structures. So whatever the wastage of reinforcement steel generally noticed at the end of after completion of the work, whatever the amount of waste is generated, so that will be noticed, or that will be identified how much amount of waste is generated. That is after completion of work, the detailed information will be identified. So bar bending schedule, the mention as per IS code 250 to 1963 as mentioned in the slide. So as per recommendation of IS 250 to 1963, they specified some guidelines, say how much length of the bar is taken, how much cutting, how much diameter of the steel bar is taken. So what purpose, how much load bearing capacity. Though in entire information will be given by IS 250 1963. A particular care is needed for a higher diameter bar while bending. So because when we are cutting the higher diameter of the bar, it will sometimes some breaking of length of the bar. So or cracking of the length of the bar or bent portion. So that's why you need to take a cutting portion or bending portion of higher diameter of steel bar. So special precautions should be taken. So generally, what type of steel bars you will select? So we have a mild steel bars or HYSD steel bar, high yield strength deformed bars. So those type of bars are generally assumed, are generally taken. And nowadays TMT bars also most benefit, a lot of benefits by using of TMT bars. So the next move on to bar bending schedule. It is the process of cutting and bending reinforcement steel into desired shape for as per structural drawing. So we already mentioned this definition. So as per given a structural drawing, as per given a drawing and codes only, we are calculating the bar bending schedule. So when we are not having a specified codes, and when we are not having a given drawings, then that time we will identify our another methods will be following. So that is approximate method is following when we are not having a drawings, when we are not having a codes, then that time we are select another method, that is approximation method. So this bar bending schedule helpful for the estimating of required quantities of various diameter of the bar. So how much diameter of the bar is selected, and how much variation of how many diameter of the bars available. So based upon the estimation only, we are knowing the quantities of a steel bar. And bar bending schedule checking the work executed as per requirement drawing and whatever the use of building, and it giving a cut and bend of a steel at the side, saving a work space and time. So the bar bending schedule give information about these things. Say member identification, bar mark, type of steel is selected. We already discussed the type of steel is nothing but mild steel or HOSD steel bar. Diameter of the steel bar, how much diameter of the steel bar is selected. So that is given by as per IS codes. So generally for slabs, 12 steel bars is selected. So length of each bar is how we are selected. So how we are calculated, length of the steel bar is calculated, length of the span, and also minus end bearings. So number of bars, how we are knowing the number of bars, that is also for by using calculation or by using estimation, we know how much number of bars is used, and the total number of bars required for slab, or total number of bars required for a beam or column. So that is also calculated in the estimation process. So these are the list. Like the diameter of the bar, as mentioned in the slide, various diameters of the bar is available. For example, 8, 10, 12, 16, up to 45 diameter of the bar. So the diameter based upon the sizes, various application is provided. So how we are calculating the unit weight of each different types of bar. So there is a formula for calculating the unit weight of a steel bar, that is d square by 162.162. So d square by 162. Here is d is nothing but diameter of the bar. So when we are placing diameter, for example 8, so 8 square by 162. Now we are get the value 0.395. Same d square by 162 is the formula for unit weight of steel bar. So when we adding instead of d place 10 10 square by 162, you will get the value 0.617. So these are the calculation of unit weight by using various diameters. Then next move on to the development length. The development length also bar is provided beyond the required sections. It will be transferring the stress from steel to concrete. It will transfer section from one element to another element. So this is the process of a bar bending schedule. So this is also called as an anchorage length. If you see in this diagram, there is some beam is there and column is there. So LD is nothing but D, or D is nothing but diameter. So whatever the mention this place, that is called anchorage length. So then move on to the next one, lap length. Lap length is nothing but the overlapping of two bars to transfer a load for installing a reinforcement steel. For example, if you want placing a where the higher load is bearing, so where that is required for overlapping cases to transfer the load from one steel bar to another steel bar. So the lap is also required when the diameter of the bar has to be changed as per design requirement. So the various lap length is provided. For example, if it is a flexural tension, the LDR 30 diameter is used. For example, if you direct tension, 2 LDR 30 diameter is used. And if you compression case, LDR 24 diameter is used. So various tension case is there. Why the tension case only mentioned? Because it resists the tension development in the bar. So lap locations also is given. If it is a column, L by 4 to the bottom, L by 4 to top L by 4 for high stress zone areas, and even beams also to resist the shear stress. So that is provided L by 3 from the support of both side of the beam, and slab also we will be getting a provide 1 by 3 from the ends. So this is the lab location diagrams point where the tension is acting. So here the tension is acting, that is the given dimension is 1 by 3, and the second portion is 2 by 3, and The column is also main bar. These are the main bars, and ground floor. These are the footings. So these are the overlapping case or lap location is provided at the top and the bottom of the member. And bends also is there. Bend is nothing but normally the requirement main reinforcement of the beam at the bottom and the top the bending is required. So here's some bending diagram is there. Bar to bar depth of the slab and theta. I already mentioned some 45 degrees or some 60 degrees will be taken based upon the dimensions, and this is the some bending shapes. The diameter is 4D